Hey guys, once again welcome to my channel Unigrabs the Learning Center. Today I'm gonna explain you about what is irrational number and rational number. And we're gonna solve lots of problems, your sums regarding this topic. Before that, if you have still not subscribed my channel, then hit the bell icon, press the red button for regular update. So let's begin. So first topic is irrational number. So what is an irrational number? An irrational number is a real number that cannot be expressed as ratio of integer. Like if we take some examples of irrational number, then we can say that all the root number are irrational number. Like pi, your lambda or root 2, root 3, anything, this all are irrational number. We can also say that irrational number is neither terminating and nor curing. Okay, taking out the value is calculating this value is little bit tough, but okay, we can evaluate the value under root. Okay, so sometimes it is also curing, but maximum of the times it is neither terminating nor curing. Or also you can say that it is an infinite number, like like decimal one, like 2.222222222. If it gone like this and never ending, or it is infinite, so it is an irrational number. Okay, so let's see a quick definition of it. A number S, here S is represented as set. A number S is called irrational if it cannot be written in the form P by Q. Okay, where P and Q are integer, or you can see the co-prime also. Okay, where Q is not equals to 0. Some example of irrational numbers are root 2, root 3, your to the power something, pi, lambda, and etc. etc. Okay, so let's see your sums regarding this irrational number topic. Our first problem is that we need to prove that root 5 is irrational number. So before proving that root 5 is irrational number, we need to see that is it rational or not. So before that we need to assume that root 5 is a rational number. So if it is a rational number, then we need to also take its co-prime also, that is P by Q. Here I took x by y as its co-prime. Okay, so after doing the cross multiplication of it, like root 5 equals to is what? X by y. X by y is your co-prime of rational number. So after cross multiplication, we get what? We get y into root 5 equals to x. Right, now squaring both the sides, what we get? We get 5 into root 5 whole to the power bracket whole to the power 2 equals to x square. So what result we get after squaring of it? We get 5y square, because root 5 into root 5 is 5 only, and y square equals to x square. Okay, so this is our first equation, right? Thus x square is divisible by 5, so x is also divisible by 5, right? Let us say that x equals to 5k. Okay, for some values of k, and substituting the value of x in equation 1, we get, like in the place of x we will write your 5k. So what we get then? So we get 5y square equals to, in place of x it is what? It is 5k. So it was what? It was x square, so it will be what? 5k square. So what your answer will be? Your answer will be x square equals to 5k square, where it is divisible by 5. It means y is also divisible by 5. Therefore, x and y are co-primes, right? Since our assumption about that this number is irrational is incorrect, hence root 5 is irrational number. Okay, so let's see the next example. In our next problem, we need to prove that 3 plus 2 root 5 is irrational. So again, like our previous sum, we need to see that is it a rational number. So if it is a rational number, then we need to find its coprime as x and y. You can take anything. You can take a, b, you can take p, q, anything, where y is not equals to 0, such that 3 plus 2 root to the power 5 equals to xy. Xy is your coprime, I said before also. Now we need to do the cross multiplications, and you get this result after rearranging. So since x and y are integer, thus let us take out 1 by 2 common out from that equation. So we get 1 by 2 in whole bracket x by y minus 3. That is a rational number. Therefore, root 5 is also a rational number in this case. But this contradicts the fact that root 5 is irrational, right? Any root 5, any root anything, root any number is your irrational number. So it is proved that it is a rational number, but the knowledge says, the contract says that root 5 is irrational. So we conclude that 3 plus 2 root 5 is irrational. Now let's see another example of it. That is 7 root 5 is irrational. So again we need to assume that is it a rational number? We need to see before proving it irrational. We need to first see that it is a rational number or not. So let's assume 7 root 5 is a rational number. So if it is a rational number, then it would have a coprime like xy. I have taken here a and b as coprime, where b is not equals to 0, such that 7 by root 5 is equals to your ab, right? So we need to do again cross multiplication of it. Then after rearranging, what do we get? We get root 5 equals to x by 7y. Since x and y are integer, thus root 5 is a irrational number, which contradicts that fact. Root 5 is irrational. Like in our definition of irrational number, what do we learn? All the root numbers are irrational number. So thus it's proved here that it is a rational number because it is an integer one. Still, it will be considered as irrational number because the rule of irrational number says that root 5 is your, or root of any sums is your irrational number. So hence it is also conclude, or it is also proof that 7 root 5 is irrational number. We're gonna see now rational number and their decimal expansions. So let us consider the following rational numbers. And number one example is 0.104. We can write this decimal number like this also now, that 104 by 10 to the power 3. Why 10 to the power 3? Because after decimal, that means after point, there are 3 digits. That's why we wrote 10 to the power 3. And if it would be 4 digit, then we will write 10 to the power 4. Like that only it will be going on. So after factorizing 104, we get 13 into 2 to the power 3, and after factorizing your 10 to the power 3, 10 to the power 3 is what? 10 to the power 3 means 1000. So after taking out the factor of 10 to the power 3, what we get? We get 2 to the power 3 into 5 to the power 3. And after deducting the numerator and denominator, like 2 to the power 3 and 2 to the power 3, we can cancel it, right? So what we get the result? We get 13 by 5 to the power 3. Let's see our second example, and that is 23.3408. So we can write like this now. 233,408 divided by 10 to the power 4. Why 10 to the power 4? Because after decimal or after point, there are 4 digits. That's the reason we wrote 10 to the power 4. So after taking out the factor of your 2,33,408, we get 2 to the power 2 into 7 into 521 by 5 to the power 4. Why 5 to the power 4? Because 10 to the power 4 means what? 10,000. That's why it came 5 to the power 4. So, you also remember one thing, that without actually performing the long division state, whether the following rational numbers will have a terminating decimal expansion or a non-terminating decimal expansion. And also write down that the decimal expansion of those rational number which have terminating decimal expansion. you also note something, that if the denominator has only factor of 2 and 5, or in the form of 2 to the power m into 5 to the power n, then it is terminating decimal expansion. And if the denominator is not in the form or not in the factor of 2 and 5, then it is non-terminating decimal number, or we can say it as an irrational number. So before doing anything, see that the denominator is in the form of 2 to the power n or 2 to the power m, 5 to the power m. If it is there in this form, then it is your rational number and terminating decimal expansion, we can say. And if it is not in the form of 2 to the power m into 5 to the power n, then it is non-terminating decimal expansion, or we can also say this is an irrational number. So let's see some example of it. So our first example is given, that first problem is given, 64 divided by 455. So we need to check either they are terminating decimal number or non-terminating decimal number. So how will we know this, that it is a terminating decimal number or your non-terminating decimal number? We will do the factor of its denominator, and if it came in the form of 2 to the power m into 5 to the power n, then only it will be terminating decimal expansion. And if it not came in the form of that, so it will be non-terminating decimal number or your irrational number. So after doing the factorization of 455, because it is denominator, right? So what we get 5 into 7 into 13. So is it in the form of 2 to the power m into your 5 to the power n? No. So it is your non-terminating decimal expansion, or you can say that it is an irrational number. Okay, why it is irrational number? Because if we divide it with it, it will come an infinity of numbers. That is, after decimal, it will come, the number will come, going on only. The number will be going on only. It will not end. That is called terminating, or that is called irrational number. Okay, let's see the next example, and that is 13 into 3000, 13 divided by 3125. Okay, so after doing factorization, after taking out the factor of 3125, what we get? We get 5 into 5 into 5 into 5 into 5. That is 5 times 5. That is 5 to the power 5. We can write, right? We can write now like that. Okay, 5 times 5 is there. So you in your mind there is a question that it is not in the form of 2 to the power m into 5 to the power n, right? So it will be not be your terminating decimal expansion, but no, it will be your terminating decimal expansion, because 5 is there. Or if 2 would be over here, then also it would be terminating decimal expansion, right? Because it has an ending point. So it is an terminating decimal expansion. So see, it is proved over here. I have given I have solved the problem over here, that how it is a terminating decimal expansion, because after doing the division it is 0, because okay, that's why it is terminating decimal expansion. Okay. Let's check another example, that is 129 divided by 2 to the power 2 into 5 to the power 7 into 7 to the power 5. Since you can see that there is your 2 to the power m into 5 to the power m, 5 to the power n denominator, it is not given in this form. Either it is given in the form is what? That is 2 to the power 2 into 5 to the power 7 into 7 to the power 5. So it is a non-terminating decimal expansion. Okay. So let's see again the next example, that is 23 divided by 2 to the power 3 into 5 to the power 2. clearly it is shown here that it is an your 2 to the power m into 5 to the power m form. The denominator is in this form only, so it is an terminating decimal expansion. So it is clear now that your terminating means what and non-terminating means what. Terminating means it is infinite, non-terminating means it is infinite, but that is after decimal the number will be going on only, and that is your irrational number or non-terminating number. And terminating number means what, it has an end. Okay, so I have solved here the problem. You can take the screenshot of it. So let's move to next. The following real number have decimal expansion as a given below. In such case, decided whether they are rational or not. If they are rational and in the form of PQ, then what can we say about the prime factor of Q? So our first example is what? 43.123456789. So you can see it has an end point. Means after 9 there is nothing, right? Because it became an end, it happened an end point, right? So it is a terminating decimal expansion, or you can say it is a rational number. So if it is a rational number, then it would have in co-primes like P or Q, P and Q. So we can write this one in the form of P by Q. Okay, and if it is a prime number, then it will also be have and factor of 2 and 5 only. Okay, so let's see our next example, that is 0.120, 1200, 12000 and 120000 and going on dot. That means infinity. So infinity means what? Non-terminating. It does not have any end point. So it is clearly you can see that it is an irrational number or non-terminating decimal expansion. Okay, so here it is proved. So I think your knowledge is clear over here, or your doubt is clear over here. But still, if you have any doubt regarding this video, then please comment it below. I will definitely help you. And till then,